I can. Good morning. Can you hear me?
Yes.
Good.
All right, let's begin. So thank you all today for coming to my defense. And I'll first thanks my advisor, Michael Casey, and Laurie, Liz, Honey, Mike Cohen, and all the MSDA cohort, and all the CS family and my family for coming today, and thanks for your time. So today I'd like to talk about my defense. That will be Latent Auto-recursive Composition Engine, which is a generative system for creative expression and human AI collaboration. So before I begin, I'd like to talk about my personal inspiration. So I think AI is like a murder lane of the ring. And it's annoying, right? And then everyone is tempting to use it because it's so convenient, it saves so much time, so much work. But we kind of don't understand what's going on, and then we feel so powerful when we put the rings on. And I would like to share a work from Megan Campbell. She made an art. It's called the Subway Lines. So basically what she did is she's in New York City. She jumped on the subway train, and then she tried to draw a straight line. And then because different lines have different conditions, so her hands will be shaken by the train, and therefore that will create a movement and also the texture of the stroke. So that's an interesting art. But the question is, the reason why we think it's interesting is because of this contextual meaning, and it's kind of saying that you just have to observe your daily life. So you can argue that we can easily write a program to simulate this randomized lines, but that doesn't mean that the AI can generate context and also the ideas behind it. So I think that will lead to this question is, can AI do art and design? So specifically, I'm curious about whether art can, people who use AI can have ownership in their art, and then also if they're trying to use AI to design, do they actually control the AI? So let's just go through some prior works. So first we're going to review the technology. So this is kind of the evolution of the AI architecture of image synthesis. We have VAE, we have GAN, we have flow-based model, we have diffusion model. But the whole idea is VAE kind of started this idea that you can encode your data into this low-dimensional representation. So it's like a memory, but you don't store the actual data. You kind of store the knowledge as future representation, and then you can retrieve it later. And now we have this GAN. GAN is really good at generating like realistic images. But the limitation of GAN is that it can't have diverse results. So that's why we have this flow-based model. And then later we have this diffusion model. So right now, the diffusion model is state of the art. And the reason why it became so popular is because we can have more control to it. So the way how it works is that we're trying to denoise. We're trying to generate an image from a noise, and then by predicting the noise, we subtract it, and then we get a clear image. And then we repeat the steps until we get a clear result. So if you look at the chart below, you can see that on the left, there's a data distribution, and then we try to flow into a normal distribution. That's for training, and then for generation that we're inferencing, we're trying to retrieve the data on the normal distribution and then go back to the data distribution. So this is the architecture of a diffusion model. They're basically flow-based. But the reason why it gets so popular is because we have this conditioning component. So you can have your text embedding, your image embedding, or semantic maps, and then you mix that into this UNet, which is another transformer-based CNN architecture, and then we throw it back to another VAE, and eventually we generate the image. And then what we usually do with Stable Diffusion together is Aura. It's for low-rank adaptation. And then what we do is, for the data set in original Stable Diffusion, we have a lot of art styles or concepts that is not included in the training data set. So instead of fine-tuning the original Stable Diffusion model, what we're trying to do is we're trying to insert a few more layers in between the original layers, and then we try to fine-tune those new layers instead of fine-tune the original layers so that we don't have to overwrite the original distribution. Instead, we kind of just plug in new styles into the model. So you can see the example on the right. That's me trying to make Jensen Huang more artistic in some illustration words. And then another thing we usually use together is the ControlNet. ControlNet is another technique that we would use to control the model. So if you look at the chart on the left, we first pre-process the image, right? So that's like different kinds of map, depth map, normal map, candy map. You can think of it as a feature extraction. And then once we got these features, we feed that into the AI model. Again, the chart on the right, the gray box is the original Stable Diffusion. We just copy a new one. It's exactly the same. Right? That'll be the blue box. And then we only fine-tune the decoder and we feed the result back. Or we only fine-tune the encoder and we back to the decoder of the original model. So in that way, ControlNet is trying to learn the relationship between the feature and the result. So then we're going to have some problems in generative AI. So the problem with this technology first is we have this entanglement of the text encoding. So if you look at the example on the left, you can see that if you're trying to generate a photo of a person, right, and we got this woman in a blue shirt. So I think that's great. So we're going to add two more words. A photo of a person with smile. We're expecting the image in the middle, but instead we get the image at the bottom. And that's a problem because by changing a few words, we completely change the composition. And same thing with the example on the right. If you look at the image, everything works well, a man and woman working on the beach. But once you add the word cloudy day, the model does give you a cloudy day, but it changed the composition completely. So that's not how we actually work when we're creating art, because we're kind of trying to iterate on current work. We don't want to completely hit work. So of course, there are many mathematical approaches trying to solve this entanglement, but that's kind of out of scope today because we're more curious about if we can solve this problem by design. So you can kind of see that if an AI artist, you're kind of doing prompt engineering. You don't know which magic word will concatenate the magic, but somehow we're kind of shooting in the air and don't know what might come out. So then I got curious. So I was wondering if AI can do logo. And I did a project that's where Lori asked us to design the logo for the USDA. So I got curious. So I collect 400,000 images of logos. So I fine-tuned the Stable Diffusion at 1.5, and here's the result. So the problem with this is that they're all looking great. They're all good graphics, right? Although the text rendering is kind of messed up. But overall, it does give you a diverse result of different designs. But how do we pick, right? We don't have this brand image. We don't have these keywords. So we don't have a good way to evaluate the result. So same thing to do with, let's just say we give it a new example. So let's say we want AI to design a logo for a sport brand, right? And we want to emphasize on aesthetic excellence, innovation, and performance boundaries. Would it give us a logo of Nike? Because this is what the official Nike goes to the website. So instead, I throw this prompt into different state-of-the-art models. So we got some Fusion, different versions, and then we got Auto 3, we got Google Gemini, we got Midjourney V6. It kind of misinterpreted the sport brand, the meaning of sport brand. It kind of gave me a sport team instead of a sport brand. And I just say we focus on this team design, right? Logo design with sport team. How do we decide which one is better? Because they all look pretty good to me, right? So we definitely need some context in order to decide the quality. And it's very difficult to write a mathematical definition to decide whether this design is good or bad. So same thing, I tried to ask the model to generate logo for Dartmouth. So the keyword is pine tree, green, and education. So here are the results. These are two sets of examples. So the x-axis is the training epoch. Right? So I'm trying to fine-tune the original model. And the y-axis is me trying to replace different keywords for the shapes. So you can kind of see we got some nice quality of graphics, but we can't really tell, right? So sometimes epoch 5 is better than epoch 15, and sometimes epoch 21 is better than epoch 10. So we don't know when to start for fine-tuning. So that's also problematic because if we even trying to use human evaluation on the quality of your model, we're going to have trouble because AI doesn't simply cannot synthesize new concepts from your text prompt. So now we're going to talk about the problem of agency. So if you have some training in art background or you have experience in AI, you can clearly tell this image is from AI. So I like to think of in this way, which is you got y-axis, where you have different models with different architecture, and then you have x-axis, that is the lens navigator, meaning you have different tools to pinpoint exactly image you want in the latent space. So I'm arguing that we're kind of missing another axis on the agency. So if you think of that, we have one for human-driven art and the other one for AI-driven art. So if you're on totally leans on the artist-driven art, that is the traditional art, and then you have this AI-driven art, then that's the current state we're in, and that's the problem because we're kind of just throwing all the heavy lifting works to AI models, where humans kind of don't spend time on the creative thinking and also the creative process. I think we should need to find a balance somewhere in between. So that's why we need to do some analysis on workflow. So for workflow 1, there are 5 workflows in total, but for workflow 1, that is the most popular way, which is prompt engineering. So we're trying to iterate the prompt by seeing the result and then changing the prompt and then see a new result and then iterate that until we get a satisfying result. So that's how most of the text to image model works. But we can do better, which is workflow 2, we have this recursive iteration in the sampling process. So instead of just constantly changing the prompt, we can feed the result back to the input and have this more consistent and coherent result. So one of the example is you can think of it as if you're trying to generate a human face, we first visualize it, we get the features, right? And then we add the features together. So you can kind of see the result at the end is somehow coherent or inherent some feature from the embeddings we got from the lab. So it's more like instead of just guessing a metric word, at least you have some idea of what you get. So that's workflow 2. And then for workflow 3, we're trying to include human in the loop. So after we create the feedback loop, we're also trying to introduce human refinement into this feedback. So one of the example is ink painting, right? So in Photoshop, we have this generative field. So basically, you generate an image with a dog on a bench, but suddenly you decided to change that dog to a cat, so you can just mask out the area and then give it a new prompt, and then say a cat sit on a bench, and then I'll generate an image. So that's having human decision into the feedback. And then what I think is interesting is workflow 4, which is human AI parallel model. So instead of having a single feedback loop, we can separate the AI feedback loop without human intervention with human feedback. So you have this 2 feedback loop at the same time. So that would create like interesting dynamics between human and AI, and that's what we mean by human AI collaboration. So one of the example is the work done by Suan Jin. She's from MIT Media Lab. She made a project called Drug Operation. And then what she did is she had this robotic arm mimicking her movement. In the meantime, she's also drawing. So the robotic arm is going to occupy the space. So she's forced to draw someone else. But when she draws something, then the robotic arm will go to the place she just draw, and then you create this interesting exact art. So last, we have this workflow 5, that's for visual reference model. So we can also try to isolate this human work and then just have this AI model as a visual reference instead of having them influence each other. So one of the examples is done by Google Research. It's called mood board search. So basically, you upload a batch of images, and then this tool will try to search similar images in the Latent space and then try to generate a mood board for you. And then you can do that for other purposes, for example, for design, for inspiration, or anything more. So now when I talk about the things I made, it's called Latent Auto-recursive Composition Engine. I call it LACE, right? Because we got all the those letters. So it's based on workflow 4 as a human kernel model. I tried to introduce a new element to it, which is this reflection on your intent. Because if your intention doesn't match the final result, that kind of doesn't make sense, right? If AI model give you something you don't want, even though it's good, but it's bad. So I'm trying to have this dual loop at the same time. I try to have human to update on the intent. So this is the look of LACE. Essentially, it's a pop-up. It's integrated into Photoshop. So the feature of LACE are here. The first one, we got text prompt. That's nothing here. And then we can have mixture of different LoRa's. We can have a control of diversity. And then we can control the level of denoising. And then we can control the influence of the user input. And then eventually we're going to display the generated result to this 3x3 tile. And if you like one of them, click on it. I'll just directly import to Photoshop. So this is how LACE works. So we have a GUI, right? That's this thing. Constantly communicate with Photoshop. And then LACE will try to collect 2 types of data. One is the snapshot of your canvas in Photoshop. And then also the GUI you're using, I've got all these parameters. We'll save it to a JSON file and we'll feed both of these into the LACE pipeline. And then LACE pipeline is connected to the AI model. And then you will generate some result and it will display it on GUI. So this is the pipeline of LACE. This is Comfy UI. I think now this is the new industry standard for prototyping AI models. So on the top left, you see this nodes for the GUI. We're passing all the data. And then we have this ControlNet for the snapshot of the image. So we're also doing image to image. And then we have this LoRa stacker, which is you can load different style of independent models together. And you can treat this LoRa as a color palette for AI. Right? So it's like pigments. So for this example, we're having this base model where it's Stable Diffusion plus impressionism. And then in addition, we try to mix with different LoRa with different styles. So y-axis is different strength for the LoRa model, and then x-axis is different style. So you can kind of see that the result is not exactly the same as the original style, but you can kind of see that it create interesting texture and then also the color tone to create new style. And I think that's the actual opportunities for artists to create something new when we say, can AI make something original or innovative? So after we have LoRa stacker, we kind of just load everything into this diffusion loader. It's like a congregation of all the data we need. And then we'll pass into this node that is in charge of diversity. I'll talk about it later. And then eventually we throw that into a sampler and then we generate the image. So for the cast, right, for diversity, I read a paper, it's called Condition on Nile Diffusion Sampler. But what it does is it's trying to inject new noise in the sampling process so that in the original diffusion model, it's trying to converge to your target. But this injection of noise will try to corrupt this process. And then therefore we try to diverge a little bit either in the beginning or at the end. and then that will give you different results. So here are example of injecting different types of noise. It could be exponential, Gaussian, or uniform. So on the left, that's the original one to generate cats. We can kind of see all the angles are like close-up shots. Like, but then by injecting this different types of noise, you can get a more diverse result. And I think that's helpful for brainstorming because we're doing art, so we want to create. So here is Blake's action. So this is me using Photoshop and then try to have this lace onto the right. And then as you can see, when I try to draw something, that will also influence the input of the air model. And if I like the result, I can also click on it and allow import the generated image and then import it to Photoshop, and then I can do image manipulation or however you want to use in Photoshop. But that kind of creates this interesting interplay between human and AI. So this LoRa is used for Matisse. So the data set is based on Matisse work. So you can see the style is color and the style is very Matisse, but I kind of change the composition and that also. Okay, so now we have lace, we need to verify whether it works. So for the experiment, I have this 3 hypotheses. The first one is, I think if we incorporate human in the loop, we'll definitely have more sense of agency and engagement. The second hypothesis is, I think lace will make the AI model more interpretable. The third one is, users are expected to value their artwork more because they have increased involvement. So for the experimental design, I create 3 types of prompt. We got representational, non-representational, and this design challenge. So the participant will be randomly assigned from one of this art prompt. And within each prompt, they will be given all 3 workflows from W1, W2, and W3. But in order to remove the bias, I randomize the order of the workflow when we test. And for each workflow, the participant might give it 15 minutes, but it's more like a software. So for W1, this is the pipeline. So the participants are given the positive prompt and negative prompts with a few parameters like random C, the ways of the control of your text prompt. So this is corresponding to the workflow 1, which is this iterative approach. And then for W2, it's essentially a combination of multiple W1. But the difference is we're trying to feed the result of W1 back into the second W1. And then we do that so on and so forth. So we're expecting by creating this feedback loop, we can somehow have this more control and to understand what's going on during the second process. And of course, we have W3, that's lace, and that's the proposed workflow that I usually mentioned about. So after each workflow, I will ask them to answer a qualitative research survey. And then specifically, I will first ask them to report their estimated time on the task. So here are the results. So I collect data from 21 participants. They're all Dharma students, and they're mostly from the NXT people and the CS people. And the prompt they're given are equally distributed to the 3 types of art prompt. And then also they have some, but not much, experience in Photoshop, and most of them have experience in Generative AI. So the results show that this is a t-test for the 6 different metrics. And as you can see, for ownership, R-score, and usability, lace, LBW3, outperform the other 2. So the baseline will just be text and image model. And lace is doing well, but it doesn't necessarily do well in the satisfaction score, the satisfaction on the art. And explain explainability of the AI model, it's also not significant. And then as for the result matching initial expectation, it's also not significant. So I put this in another perspective, which is on the engagement. So in the light orange is the user estimated time. The dark orange is the actual time. So as you can see, from W1 to W3, as the task increase progressively, the complexity of the workflow increase progressively, the engagement does increase. And then you can kind of notice that in W2, we have this discrepancy in between the estimated time and the action time. And then if you also put it with the ownership, the y-axis, you got this blue dots, you can kind of see that, yeah, sure, W3 is way better than the other two, but ownership in W1 and W2 doesn't have much difference. So it doesn't mean that the workflow is complicated without for ownership. So I also try to view it in a different types of art prompts. So I try to put it into 3 different groups. So as you can see, for representational and design prompt, the engagement does increase progressively again from W1 to W3, and the estimated time always exceed the actual time. However, in T2, for the abstract art, we can see that actually the user reported time is actually shorter than the actual time. So what's going on? And then also, I try to view the engagement based on the satisfactions. So here I create 3 intervals for 1 to 2, and then 3 to 5, and then 6 to 7. And then you can see that for W1, and that's text to image, the basic one, there's no low satisfaction, meaning that it can't go wrong. If you type something, Stable Diffusion is trained really well, so it can't go bad. However, you can notice that the engagement, if you have high satisfaction, will actually decrease. So meaning that if they get lucky, right, they get the right words, they have a good result, and then they kind of stop the task, because when I ask the participant to stop the task when they get a satisfied result, so actually they spend less time on it. And then as for W2, I was thinking that, oh, maybe they're satisfied with the result, they'll have more engagement to it. But then instead, I also get this high satisfaction group also doesn't have more engagement than the median satisfaction group. And if you look at this high satisfaction groups in all 3 workflows, you can kind of see that they're not the highest in every workflow. So that's telling something, and I'm talking in conclusion. And then also in W3, right, that's the tools that I made. In low satisfaction score, one of the participants actually spends so much time. Although they get a dissatisfied result, but it's trying to fix the result so hard that actually to spend even more engagement to it. So that's just look at the result. So this is the result from T1. I'm asking them to generate a man looking at a painting in the gallery, and also this dog sniffing another artwork around. So you can kind of see that the quality of not that bad, but for W3, it's more accurate. And then you can kind of tell that from W2, we have this turbulence in the style, because sometimes it's abstract art and sometimes we don't have dots in it. So at least for W1, we have dog in every image. And then as for T2, that's for the abstract art to create something about joy. We can kind of see that the result is very inconsistent. So we have all kinds of different styles, and there's no coherence in between the workflow. And then arguably the quality in W3 is actually not as good as W1. So we can kind of still see that even though we have a lot of degree of freedom, that doesn't mean that the model is explained. And then last, for T3, I'm asking participants to create pixel arts for the city landscape. So you can, again, you can kind of see that W1, W2 is working pretty well. However, in W2, we have a fatality. So that's pretty weird. So the key finding is by having human in the loop, it surely does enhance user engagement and ownership. However, more engagement doesn't necessarily mean increase of ownership. And then also the actual factor that increase the engagement is actually the task complexity and the learning curve of the given tool. So if user got frustrated, right, they get the result mismatch from their initial intention, they actually depend more on AI, right? They're trying to take the shortcut and then replace that's over there. And also with layers, right? Even with layers, we have so many parameters to play with. We still have this transparency issue with the AI model. So back to our hypothesis, we kind of verified that the first two does work. However, for the last one, by having more involvement, they will appreciate their artwork more. That's actually not the case. So I would say that for future work, we'll definitely, I'm curious that if we, because for most of the participants, they'll just see as students. So I'm curious if we include some people from the art background, like traditional art background, they might give us different feedbacks and different evaluation. And also, I think for this human AI parallel model, it's going to create this interesting dynamics where we can definitely investigate deeper. And then as for this visual reference model, I'm doing a test. I barely observe anyone's doing this, although Lace is capable of doing that, but most people just treat this tool as an advanced version of text-to-image model. So I think we can definitely focus on this human AI interaction. And by doing the approach of design, we can definitely scope the sum of the problem and make it more interpretive. So to wrap this up, I think art and design definitely extend beyond the aesthetic. So we must include culture, context, creativity, and then in generative AI, we definitely have to prioritize human-centered computation. And then I think many of the problems can be solved through design and then watch. So that's it.